So hello everyone, welcome to the channel. So in this video I'm gonna show you urban heat island mapping using MODIS LST night imagery in Google Earth Engine. So now let's get started. So urban heat island refers to the phenomena where the urban or the metropolitan areas experience slightly higher temperature than the surrounding rural areas. So this temperature difference is primarily due to the human activities that replaces the natural land cover with a surface that absorbs and retains heat such as asphalt, concrete and building. So other contributing factors includes the waste heat from the vehicle and industrial processes and reduced vegetation and the geometric arrangement of the building that traps the heat. So the urban heat island effect is the most pronounced during the night when the rural area cools down faster than the urban area. So the consequence of this urban heat islands are multiphased and severe. So the elevated temperature in urban areas can lead to an increased energy consumption, for example using air conditioning system, and elevated emission of these air pollutants and greenhouse gases, and compromise the human health and comforts, including the heat related illness and mortality, and reduced water quality due to the heated runoff. So, understanding and mitigating the urban heat island is therefore a critical for sustainable urban development and climate change adaptation. So, the remote sensing technology, particularly satellite based thermal sensors, has become an indispensable tool for studying the urban heat island. So, for example, the moderate resolution imaging radio spectroradiometer aboard NASA's Terra and Aqua satellite provides a consistent and global land surface temperature data, making it an ideal for urban heat island analysis. So, Earth Engine offers a powerful platform for processing this large geospatial datasets such as MODIS without a need for the local computational resources. So, in this video, first we're going to initiate by importing the administrative boundaries and defining the point of interest to extract the corresponding spatial regions. And using MODIS Terra LST 8-day composite product, it filters and processes the nighttime surface temperature data from January to March 2020. So LST is then scaled and analyzed to calculate the mean winter temperature over the selected area to detect the heat intensity, and urban heat island index is computed using the formula T minus mean divided by mean, where the T is the local land surface temperature and mean is an average temperature across the study region. So the result is a spatial representation of the temperature anomaly indicating the urban heat island intensity. So this urban heat island index is visualized as a continuous heat map, and further we're going to classify it into a severity level starting from weak to extreme levels, and to ensure the relevance only within the city and the MODIS urban land cover classification is used to mask the result and isolating the urban heat island intensity to urban areas only. And the final output we're going to export as a geotiff for use in a decision support and urban planning. So now let me get back to Earth Engine. So now first we're going to load our administrative boundary into Earth Engine. So to load our administrative boundary, so first we're going to define a variable called admin boundary equals to Earth Engine dot feature collection FAO 2015 level 1. So this particular code which is going to refer this particular administrative boundary layer. Let me show you that. So FAO Global Administrative Unit Layer 2015. So the dataset availability is from 2014 and the dataset provider is FAO UN, and using this particular code you can access this particular dataset here. And the Global Administrative Unit Layer compiles and disseminates the best available information on administrative units for all countries in the world, providing a contribution to the standardization of spatial dataset representing in the administrative units. So you can go through the details about this particular dataset here. It will be given in the description section. Let me get back to Earth Engine. So the next step, we're going to add this layer. So to add this layer, we're going to define map.addLayer admin boundary with the default visualization parameter, and we're going to output the layer name as admin boundary. So once you did that, next I'm going to run this code here. So now here you can able to visualize. So we have loaded our administrative boundary layer in Earth Engine. So this is a global administrative boundary layer. So you can select your study area of your choice. So for example, I'm going to select this particular study area, that is this particular state as my study area, that is Gujarat. So to select this particular boundary as my study area. I'm going to place a point over this particular study area using this option called add a marker. So click this and place a marker over your study area or your desired region. And in order to select this particular boundary area, so for that I've placed this particular point data here. So once you place it, I'm gonna exceed this, and I'm gonna navigate to the top section here, and I'm gonna click this option called show generated code. And in the generated code, I'm gonna copy the latitude and longitude of the study area, and using Control C in my keyboard, once you copied your latitude and longitude, so I'm gonna paste this particular value inside this variable. So I've selected this particular latitude and longitude, so I'm gonna paste my latitude and longitude using Control V in my keyboard. So once you pasted it, next we're going to define the variable focus point equals to earth engine dot geometry dot point. So basically this particular is going to convert this particular latitude and longitude into a point data. So for that we are using the earth engine dot geometry dot point. So in the next step we're going to filter this particular boundary out using this particular boundary out from this data set using this particular variable called focus point. So where we converted this latitude and longitude into a point, using the point we're going to filter this particular study area boundary. So for that we're going to create this particular variable called analysis region equals to boundary admin boundary, referring to this particular variable, and we're going to apply some filter function dot filter bound focus point. So focus point refers to this particular variable, so you can able to see that, and in that so we're going to apply a map function here. So I'm going to apply dot map function feature. So basically we are applying this particular map function in order to simplify the geometries to reduce the complexity of this boundary layer. So I have defined dot map function feature and written feature dot simplify 1000. And in the next step I'm going to mention map dot center object analysis region. So it's going to center this particular boundary here. And last, to add this layer, we're going to define map dot add layer analysis region with the default visualization parameter and output the layer name as administrative region. Now let us take a look at the layers here. So I'm going to navigate to this particular option. I'm going to turn on this admin boundaries and I'm going to turn on this administrative region. So now here you can able to visualize we have managed to filter out this particular boundary out from the admin boundary layers. So in the next step we have to fix some time period for our analysis. So in the next step we have to define our time range for our analysis. So for that we're going to define a variable called variable year start equals to 2020 January 1, and followed by we have to specify the end period of our analysis. For that we're going to define another variable called year end equals to 2021 January 1. So in the next step we're going to load a MODIS nighttime land surface temperature data in Earth Engine. So let me show you that data set here. So MODIS Terra land surface temperature and emissivity, so 8-day global 1 kilometer resolution dataset, and the dataset is available from 2000 to 2025, and dataset provider is NASA. So using this code you can access this particular dataset, the land surface temperature dataset, and you can go through the description about this particular data. So MODIS product provides an average of 8-day land surface temperature in 1200 by 1200 kilometer grid, and you can go through the detailed description about this particular dataset. So let me navigate to the band section here. So in the band section you can able to see that the resolution of this particular dataset is around 1000 meters, and these are the following bands that is available in this data, starting with LST day 1 kilometer, so the day land surface temperature, and similarly we have another band called LST night 1 kilometer, so it is night land surface temperature band. So for our analysis we're going to use this particular band called LST night 1 kilometer. So now let me navigate to the Earth Engine. So to access this MODIS LST dataset, first we have to define a variable called MODIS LST night equals to Earth Engine dot image collection MODIS 061 mode 11A2, and next step we're going to select this particular band called LST night 1 kilometer. So we're going to select this particular band called LST night 1 kilometer band. So for that we're going to mention dot select LST night 1 kilometer. So the next step we're going to apply the filter based on the time period of analysis. So for that we're going to mention dot filter date, year start and year end. So year start is mentioned here and the year end is mentioned here. That is start data for analysis and the end data for analysis. And followed by, we're going to filter it based on specific month here. So for example, we're going to specifically view the land surface temperature of this particular study area during night time for this set of month here from January to March. So for that, we're going to mention dot filter earth engine dot filter dot calendar range 1 to 3 and the unit in months. So January to March. And next we're going to apply a median function in order to acquire a median image. So for this specific timeline, so for the specific timeline contains a lot of imagery, so to acquire a single median image, so for that we're going to mention dot median function. And last we have to apply the scaling factor to our dataset using dot multiply 0.02. So this is a scaling factor which is given in this data here. So you can able to see here the scaling factor which is around 0.02. It's given here. So we have to apply the scaling factor before proceeding towards our analysis. So next step, we're going to add this layer. So to add this layer, we're going to define map.addLayer modis LST night dot clip. So based on our region of interest, that is analysis region. And we have to apply some visualization parameter using a minimum of 250 and to a maximum of 320. And these are the following set of color palettes starting with blue, green, yellow and red. And we're going to output the layer name as winter night LST, that is land surface temperature. So in the next step, we're going to calculate the mean winter temperature over the study region. So to calculate the mean winter temperature, so we're going to define another variable called mean winter LST equals to earth engine dot number modis LST night, referring to this particular variable, and dot reduce region. We are applying statistical function, so that is reducer. So we are defining earth engine dot reducer dot mean function, so to acquire a mean temperature over the region. And next the geometry, referring to our study area, that is our analysis region, and followed by the scale, that is 1000 meters of resolution, and dot value function dot get. So to get the first value out of this out of all the values, so to get the first value we mentioned as dot get 0. And in the next step, we're going to compute the urban heat island index. To compute, so we are using this particular formula to calculate the urban heat island intensity. So for that, we're going to mention this particular formula, that is LST minus the average LST divided by the average LST value. So the formula to calculate the urban heat island intensity, it is the LST minus the mean LST divided by the mean LST. So to apply the urban heat island, so we're going to define another variable called UHI index is equals to modis LST night, and we are going to apply some this expression dot expression, and we're going to mention the formula LST minus the average divided by average. So LST refers to modis LST night time data, and the average value which refers to this particular variable where we computed the mean LST value during the winter time over this particular study area. So we're gonna use this LST minus average LST divided by average. So it's gonna give us the urban heat island intensity. And last, we're gonna rename as UHI index. And to add this layer, we're gonna define map.addLayer UHI index, referring to this particular variable, and we are applying clip function based on our study region, and we are gonna apply the minimum and maximum values and the color palettes starting with the blue, white and red. So blue, which indicates the lowest urban heat island intensity, and the red, which indicates the highest urban heat island intensity. And we're going to output the layer name as UHI index. And now let us visualize the results. So we're going to navigate to the run section, and we're going to click run to visualize the result. So our study area lies in this particular, that is our Gujarat. So Gujarat is our study region. So now the layers are getting loaded up here. So we're going to turn on this UHI index. So based on the color palette, you can able to see the highest temperatures are indicated in red color. So we can able to see in this study area. So we can able to visualize red color here. So you can able to see here, and the moderate level of temperatures are indicated in white color, and the lowest urban heat island index is indicated in blue color. So the red, which indicates the highest urban heat island, and the white which indicates the moderate level of urban heat island, and the blue which indicates the low level of urban heat island. So based on this figure, you can able to visualize the result here. So only towards the northern part has a higher red values, compared to the other part of the study area has a lower values, and fewer areas which indicates the white areas which indicates the moderate level of urban heat island. So you can able to see from this particular imagery. So next step, we have to visualize this particular result in the histogram. So in order to visualize the range value of this urban heat island effects, so to do that, we have to create a histogram. So for that, we're going to define print ui.short.image.histogram and UHI index referring to this particular variable, where we done our formula to calculate the urban heat island effects. And last, we are referring to this particular analysis region, that is our study area. And here we mentioned the value of 1000, which indicates the resolution of this particular imagery. And last, we're going to set some additional options to this particular chart here using dot set options. And the title I'm going to mention is histogram of UHI, that is urban heat island intensity. And in the v-axis, the title I'm going to mention as frequency, and the h-axis, the title we are going to mention as UHI, that is urban heat island index. So we're going to navigate to this option called run, and we're going to click this option called run script. And now let us visualize the histogram for this urban heat island effect for this study area. So you can able to see this particular histogram, that is histogram of urban heat island intensity. So this is a frequency, and this axis represents the urban heat island index. You can able to see from this image here, so value which is more than 0.02 to values ranges from 0.00 to 0.02, and even the minus value is also occurring in this particular imagery. So generally we're going to focus on the positive value. For example, if the value is ranging from greater than 0.0 to 0.000 to 0.005, which indicates the weak urban heat island index, and if the value ranges from 0.005 to 0.010, which indicates the moderate urban heat island effects. So let me show you this particular table. So from this table, you can able to visualize the urban heat island severity classification. So the severity, for example, the weak value, so which indicates the weak category, which indicates that if the urban heat island index value ranges from 0.000 to 0.005, which will be indicated in the light blue color, and followed by the severity, the moderate severity of urban heat island index, which will be indicated in the value ranging from 0.005 to 0.010, which will be indicated in the yellow color in our imagery, and followed by the strong urban heat island effect, which will be indicated in this value starting from 0.010 to 0.015, and last, the very strong urban heat island effect is indicated in this value starting from 0.015 to 0.020. And let me get back to Earth Engine. So based on our histogram here, our value generally ranges between 0.00 to 0.02, which is ranging in this category from weak to very strong urban heat island effect. So in our study area, the value is ranging from weak to very strong urban heat island, which is ranging from 0.000 to 0.020. So let me get back to Earth Engine. So once we got the necessary values, that is the range value of the urban heat island index for our study area, so the next step, we have to further classify this urban heat island index into several categories based on the severity of the urban heat island. So in the next step, we're going to classify the urban heat island index into severity categories based on the value obtained from the histogram here. So starting with, we're going to define a variable called UHI severity equals to earthengine.image.constant 0, where UHI index greater than or equals to 0.000 and UHI index is lesser than 0.005, and comma 1, we're going to mention that as the first category, that is weak category, weak urban heat island, and followed by in the next category we're going to define dot var UHI index is dot greater than or equals to 0.005 0.005 and UHI index is less than 0.010 which is represented as 2 as a category 2, that is moderate urban heat island, and followed by the third class is the where when the UHI index is greater than or equals to 0.010 and the UHI index is less than 0.015, which is the third category, that is strong urban heat island, and followed by in the next category where UHI index dot greater than or equals to 0.015 and the UHI index is lesser than 0.020, which is indicated in the fourth category, is very strong urban heat island. And the last category is where the UHI index is greater than or equals to 0.020, which is indicated in the fifth category, which is extreme urban heat island. So once we have classified the urban heat island into several severity categories starting from weak to extreme, so in the next step we're going to add this layer. So to add this layer we're going to define map.add layer UHI severity dot clip based on our study area, and we're going to set the minimum of 1 and the maximum of 5 based on the 5 classes starting with weak, moderate, strong, very strong and extreme. And these are the following set of color palettes for each of this category, starting with light blue, which is weak, and yellow is moderate, and orange is strong, and red is very strong, and maroon it is the extreme urban heat island index. And we're going to output the layer name as UHI severity classification. So now let's take a look at this particular layer. I'm going to navigate to the run section and click run. So in the layer section here, so we're going to turn on this particular layer called so let me turn on the urban heat island severity classification. So I'm going to zoom in to our study area. So the layers are getting loaded up here, so you can able to see. So the urban heat island is severity classification layer. So we are currently visualizing the urban heat island severity classification imagery. So based on this image, you can able to see here the maroon colors, which is indicated towards the northern part of the study area here. So you can able to see here. So these are the areas which indicates the very high urban heat island effects were observed, and similarly towards this part of towards the north western part of the region. So you can able to see the urban heat island, so which is pretty higher compared to this areas here. And also towards the central part of the area, all the urbanized area, let me turn to a satellite mode, and let me turn off all other layers here. So now we're going to zoom into this particular study area. So you can able to see here, this is a highly urbanized area. So based on our satellite imagery, this is the highly urbanized area. So on the urbanized area we have this very high urban heat island effect observed based on this set of colors here, starting with the red, orange and yellow. And similarly, so I'm going to navigate towards the northern part of the study area. So here you can able to see, so this particular area has a very high urban heat island effects. So from this image, based on this image, you can able to see this particular area has a very high urban heat island effects. So let me turn this layer off. So we're going to visualize this particular area here. I think it's kind of an industrial area, so so you can able to see that. So this particular area has a very high urban heat island, and the next step we're going to turn on this and visualize the other places too, and also towards the northeastern part of the study areas too has a higher level of urban heat island effects, and also towards the southern part of the area. In this particular area, that is Surat, has a very high urban heat island. So in the next step, we're going to load our MODIS land cover types and apply the urban area mask for the same year. So to do that, first we're going to define a variable called urban mask equals to earth engine.image collection MODIS 061 mcd1 to q1. So let me show you this particular data set here. So this is the MODIS land cover type yearly global 500 meter resolution land cover data set, and the data set availability is from 2001 to 2023. And the dataset provider is NASA. So using this particular code, you can access the land cover data of MODIS of 500-meter resolution. So these are the following bands that is available in this dataset here, and there is a lot of bands that is available. For example, we're going to select this particular band called LC Type 1 and the land cover Type 1 Annual International Geosphere Biosphere Program classification. So we're going to use this particular band. So now let us take a look at the in this band what are the different land cover types available in this band of LC Type 1. So in LC Type 1 class table, these are the following land cover types that is available. So around 17 land use classes are available in this data set here. So our interest is to specifically on this particular class called urban build-up areas. So this is the particular class of our interest. So we can able to see this is the at least 30% impervious surface area, including building material, asphalt, and vehicles. So we're going to select this particular class, that is class 13, urban and build-up lands. So we're going to select this particular land cover class, and we're going to mask this land cover class and visualize the urban heat island for all the urban areas in the study region. So let me get back to Earth Engine. So to access this data, we're going to define this variable called urban mask equals to Earth Engine dot image collection modis 061 mcd12q1, and in that we're going to select this particular band called LC Type 1 as I've mentioned earlier, and we're going to apply the temporal filter, that is dot filter date, year start and year end. And last, we're going to select this particular option called dot first function. So we have applied the first function in order to select the first land use image. So for that we mentioned dot first function. So next we're going to mention dot equals to 13, that is eq equal 13. So 13 here, which represents the urban and build up. Let me show you that. So the 13 here, which represents the urban and build up plans. So for that I have mentioned as eq 13. And last we're gonna add this layer map.add layer urban mask, referring to this particular variable dot clip function based on our region of interest. So we're gonna clip it based on our region of interest, and we're gonna mention the default visualization parameter for this layer, and we're gonna output the layer name as urban area. So now let us take a look at this layer. So let me navigate to the layer section and turn on the urban area. So now here you can able to visualize all the whiter areas, which indicates the urban class, and all the darker area which going to represent the other land use classes. So we're going to specifically focus on this urban areas, that is white areas, or these white areas are the urban areas in the study region. So we're going to select only this this urban class, and we're going to mask the urban class. So to do that, in the next step, we're going to mention to mask the urban heat island classification to only urban areas. We're going to define another variable urban UHI equals to UHI severity. So UHI severity, which referring to this particular variable we already defined here in the categories, and in that we're going to mention dot update mask, and we're going to mention inside this variable urban mask, referring to this particular variable. So now it's going to show only the urban areas in the study area. And next, to add this layer, we're going to define map.add layer urban UHI dot clip based on our region of interest, that is analysis region, and we're going to set the minimum of 1 and to a maximum of 5 value, and color palette starting with light blue, which indicates the lower urban heat island, and the yellow, orange, red, and maroon, which indicates the highest urban heat island. And we're going to output the layer name as urban UHI severity. And now let us take a look at this particular map here. So we're going to turn on this layer urban UHI severity. So it's going to load the layer here, so you can able to see the values here. So all the major urban areas has a value ranging from the color ranges from maroon to red to yellow, which indicates the moderate to very high moderate to extreme urban heat island. So you can able to see from this figure here. So that is from this image here, so we can able to see. So for example, I'm going to zoom into this particular study area, and I'm going to turn off all of the layers. So this is an urban area. So you can able to see the value ranges from red orange and yellow, which indicates the moderate to strong urban heat island. So let me zoom out. So the next step, we have to export this particular imagery to our Google Drive. So to export it, we're gonna mention export dot image dot drive. So we are exporting the urban UHI classification map to our Google Drive. So we're gonna mention this export dot image dot to drive. Image is urban UHI dot clip. That is our based on our region of interest. And description, I'm gonna mention the urban heat island severity, and the resolution I'm gonna mention is around 1000, and the region is our study area, that is analysis region, and the max pixel value, and the coordinate reference system, and to the folder. So now we're gonna run this. So now we're gonna navigate to the task section here. So it's gonna load up here. So we're gonna click this option task, and in that we have this unsubmitted task called urban heat island severity, and we're gonna click this option called run. And here you can able to visualize, we have this window pop-up saying initiate image export. So the task name is urban heat island, and the coordinate reference system, and the spatial resolution of this imagery, and we're gonna export it to our Google Drive. So you can also export to a cloud storage and Earth Engine asset. So now we're gonna export to a Google Drive, and the drive folder is urban UHI, and file name is urban heat island severity, and the file format is in GeoTIFF. So now to export this particular imagery, we have to click this option called run to export this image to our Google Drive. So next we're gonna take a look at the application part of this particular analysis.